Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class A. This is for session R18. For question number 26, the question says the width of a box is 1/3 of its length. If the height of the box is 1/3 of its width, and the length of the box is 27 centimeters, what is the volume of the box? So here it's helpful to first start with a rectangular prism, and this has dimensions length times width times height, and that's how you find the volume. So for a prism, it's going to be LWH. Now you know that the length is 27, and then the width is 1/3 of its length. So 1/3 means 1/3, and of means times. So you take 1/3 times 27, and that's equal to 9. So the width is equal to 9, and the height is then 1/3 of its width. So the height is again 1/3, and of means times. This times the width is 9, so you do 1/3 of 9, and that's equal to 3. So in this case, when you find the volume, you'll be doing 27 times 9 times 3. That's really 27 times 27, or 27 squared. So when you multiply through, you get 729, which is choice D. So you have to use the formula for the volume of a prism, which is LWH, and you use the keywords of, which means multiply, to figure out the length, the width, and the height. Next, for number 27, how many possible outfit combinations come from 6 shirts, 3 slacks, and 5 ties? The keyword here is combinations, and when you have combinations here, you can use the counting principle. And the counting principle is a shortcut of the tree diagram. So for this counting principle, you want to write out all the options you have for shirts, which you have 6 shirts, for slacks, which you have 3, and for ties, you have 5. And you always want to multiply for the counting principle, so this will be 6 times 3, or 18 times 5, which is equal to 90. So the answer is choice D, 90. The other way to represent this is by using a branching diagram. So you branch out to 6 shirts, and then each of these shirts will then branch out 3 times for the slacks, and each of these slacks will then branch out 5 times. So you end up with a lot of branching points. First 6, then 3, and then 5, so you get a total of 90. So you have a lot of options here. Next, for number 28, a bank is offering 4.5% simple interest on a savings account. And if you deposit $8,000, how much interest will you earn in 5 years? So interest is the extra money that the borrower pays the lender. And in this case, the bank is borrowing your money if you put money into a savings account. So the bank will give you extra money for putting and depositing some money in there. The formula is I is equal to P times R times T, where I is the interest rate, the interest, and this is the extra money. P is the principal amount, or the starting amount. R is the interest rate, and this is usually in a decimal. You can also use percent or fractions. And T is the time, and this is time in years. So you just substitute in the numbers that you have. In this case, 8,000 represents the principal. The interest rate is 4.5%, but you got to turn this into a decimal. So this would be 0.045, because you have to move the decimal to the left 2 places. That's what a percent means. Percent means divide by 100. So So the interest rate is 0.045. Now be careful, it's not 0.45 because 0.45 is 45% interest, which is 10 times as much. And finally, you have the time, which is 5 years. So you just take these three numbers, you multiply it together, you have 8,000 times 0.045 times 5. And here, this is really 4.5 over 100 times 8,000. The two zeros will cancel out. So you have 80 times 4.5 times 5. So from here, you can estimate 80 is about $100. 4.5 is about 5, and 5 is about 5. So if you multiply, you'll get around 2,500. And choice C is less than that because we did round up. If you do multiply 80 times 5, that would be 400 times 4.5. And we do 400 times 4.5, you get exactly $1,800. So that would be choice C. There will be an extra $1,800 in the bank account after 5 years if you are earning 4.5% simple interest. So for this question, you use the simple interest formula, I equals PRT, to figure out how much extra money you have in this bank account after a set number of years. So just remember that I is the interest, extra money, P is the principal amount, or starting money, R is the interest rate, and it's always in decimal, and T is the time in years. Next, for 29, you have this table above that shows the distribution of age and gender for 30 people in a company. If one employee is selected at random, what's the probability that the employee selected will be either a female under 45 or a male 45 or older? So here, if you have either and or, this means you want to add the probabilities. So if you have a probability or chance question, which is part over whole, for probability questions, and means you want to multiply the percentages, whereas or means you want to add the percentages. In this case, you have the probability of female less than 45, or the probability of a male greater than 45, or means you want to add the probabilities. So the chance of selecting a female under 45 is over here, 5 out of the total of 30. And you're going to be adding that to the probability of getting a male over 45, which in this case is a 6, over, again, the same total of 30. When we add these together, you have 11 over 30. So 11 of these 30 employees will fit the criteria of either a female under 45 or a male over 45. So again, for this question, you have probability, which is a chance, so that's part of a whole. And for probability questions, and means multiply, or means add. So in this case, it's an or problem. So we'll be adding the two probabilities. And together you have about a 1 in 3 chance of selecting someone that fits the criteria. And here is the summary for this page. Next, for number 30, the cost in thousands of dollars of producing X thousands of textbooks is C of X is equal to X squared plus 2X. The revenue, also in thousands of dollars, is R of X is equal to 40X. Find the profit or the loss if 30 textbooks are produced. So you have the equation profit is revenue divided by, subtracted by, the cost. So here you have two functions. A function is just an input-output machine. And you put in X as the input, in this case for the cost function. You put in X, which is the input, which in this case is how many books you want to make. Put into function C, you get the output Y. In this case, Y is equal to C of X. This will give you how much it's going to cost. Revenue is the money received. So the revenue function is, again, you put in X the input, which is the number of textbooks, to this R function, and you get the Y, where Y is equal to R of X, and this is how much money you're going to receive from that. And profit is the revenue function, subtract the cost function. So total profit is total revenue minus total cost, as stated here. So that's going to be, let's call this P of X, will be equal to R of X minus C of X. So you take these two functions and you just subtract. And in this case, you want to find P of 30, which means you'll have to substitute in how much money you get after making 30 books minus how much it's going to cost you to make 30 books. So R of 30 means everywhere you see X, you're going to place it with 30. That's going to be 40 times 30, or 1,200. So you'll get $1,200. And you're subtracting C of X, or in this case C of 30, which means everywhere you see 30, you're going to replace it with everywhere you see X, you're going to replace it with a 30. So this will be 30 squared plus 2 times 30, and this is all in parentheses, so we have to subtract this whole thing. We can also distribute the negative sign. So when you subtract 30 squared is 900, plus 30 times 2 is 60. So what you have is 1,200 minus 960, which is equal to 240. And you're making profit, which means you're making money. And the answer is choice B. So for this case, for this problem, you have a function, or two functions, which is the input-output machine. You have the profit function, or excuse me, the cost function, how much things cost you to make 30 books, and the revenue function, which is how much money you get, this is cash on hand, after a day or so, to figure out, how much it's going to cost you each day to make 30 books or whatever. So in this case, you have the total profit is equal to total revenue minus the total cost, and you just have to subtract the functions here. But you're going to replace it with 30 because X would be 30 in this case. So you figure out how much it costs to make 30 books, over here. You subtract that from how much revenue or the money you receive from selling 30 books, and that will give you the profit, how much money you make after producing 30 books. So that's something to keep in mind. Profit is not the same as revenue, because profit includes the negative costs. So if you buy a book for $10 and you sell it for $11, you didn't make $11. You actually only made $1 because it cost you $10 to buy the book. So that's the idea behind this. So don't confuse profit with revenue. Revenue, you have to subtract profit. For profit, you have to subtract the cost from the revenue. Next for number 31. What is the length of AB in the following figure if AE is equal to 4, CD is equal to 6, and AC is equal to 12? So for this problem, we have two triangles, and for these two triangles, we know that AE is 4, CD is 6, and AC, this whole thing, is 12. Now AC is made up of two different lengths, so we can call A to B X and B to C Y. You know that X plus Y is equal to 12. Well, the other thing to note is that we have this angle EAB is equal to this angle CBD. So these are vertical or opposite angles, and these are congruent. And this is the X formation. If you have the top and bottom angles for this X, they are in fact equal. So if that's the case, and we have this right angle is equal, we can use the AA theorem to state that these two triangles are similar. So triangle ABE is similar to triangle CBD. So the angle, the order does matter. ABE and CBD are both going to be similar triangles. And similar means it's the same shape, but it's a different size. Specifically, the sides are proportional. So if you look at the proportion, you go from 4 to 6. So the small triangle has a side length of 4. The big triangle has a side length of 6. So you know that 4 times 1.5 or times 3 over 2 is equal to 6. So that means you have to multiply everything by 3 over 2 to go to the big triangle. In this case, since the factor is times 3 over 2 or times 1.5, that means that to go from x to its corresponding side in the larger triangle y, you have to multiply by 1.5. So that means that y is equal to 1.5 times x, or 3 over 2 times x. And now you have a system of equations here in which you can do substitution. So if x plus y is equal to 12, you know that y is equal to 1.5x. So x plus 1.5 times x would be equal to 12. And the coefficient of x is 1. So essentially this means that 2.5 times x equals 12, and you can divide by 2.5 on both sides. So x would be 12 over 2.5, or if you move the decimal over, this would be 120 over 25. And to simplify 120 over 25, you can divide top and bottom by 5. And that will give you 24 over 5, which is 4 4/5, or 4.8. So x would be equal to choice B, 4.8. So for this question, you have to use the similarity here through the AA theorem, the angle-angle theorem, which means that you have the same shape but different size. And we figured that out because you have vertical angles here and this 90-degree angle, which allowed you to determine that these two triangles are similar. And because they're similar, you can set up the proportion by relating the corresponding sides 4 to 6. So in this case, this side of 4 corresponds with the side of 6. And you figure out that it is a 1.5 times ratio. So then you set up your system of equations. X plus y is 12, and y is 1.5 times x, which then allows you to do substitution over here to solve for x as 4.8. Next, for number 32, if the area of the following trapezoid is 126 centimeters squared, then what is the perimeter of the trapezoid? So we have an area, and we want to figure out the perimeter. Well, for a trapezoid, you know that all trapezoids can be broken down into a rectangle and a triangle, and for this rectangle, the opposite sides are equal. So you have all the ingredients to figure out the area of the trapezoid, which is going to be 1/2 base 1 plus base 2 times the height h. So you take the average of the two bases, base 1 and base 2, and you multiply it by the height, which is perpendicular to the bases. So in this case, the area is given as 126, will be equal to 1/2. Base 1 is 8. Base 2 is going to be 8 plus 5, or 13. And the height is going to be x, and that's going to be our variable. So to solve for this, you can multiply both sides by 2. Cross out the 1/2. To get 252 is equal to 8 plus 13, or 21 times x. You can divide by 21 on both sides. You get that x is equal to should be 12. So we do 252 divided by 21. Yes, this is exactly 12. So once you know x is equal to 12, then you can zoom in on this right triangle here. And for this right triangle, you have to use Pythagorean theorem, which states that a squared plus b squared equals c squared. But there's a shortcut. These are actually two of your triplets. So you have to remember 3 for 5 and 5, 12, 13. This is the ladder. So you have a 5, a 12, so y will be equal to 13. And this will help you find the perimeter because you have 13 for the bottom, 8 for the top, 12 for the left, and 13 for the right. So if you add 12 plus 13 plus 13 plus 8, that gives you 25 plus 21, or 46. So perimeter will be choice C, 46 centimeters. So for this question, you have to use the area of a trapezoid formula to work backwards to find the height, which you found out to be 12. Once you find the height is equal to 12, then you can use Pythagorean theorem or the triplets, specifically 5, 12, 13 triplet, to figure out the hypotenuse of this triangle, which then will help you find the perimeter when you add up 12, 8, 13, and 13. Next for number 33, in 5 successive hours, a car traveled 40 kilometers, 45 kilometers, 50 kilometers, 35 kilometers, and 55 kilometers. In the next 5 hours, it traveled an average speed of 50 kilometers per hour. Find the total distance that the car traveled in 10 hours. So the first 5 you already have. So you have 40, 45, 50, 35, and 55. You add that up. This is 10, this is 8, and then you have another 4. So this would be 22. So you already have 225 miles or 20 kilometers for the first 5. But then the next 5 hours, you have an average speed or rate of 50 kilometers per hour. You have your time, which is 5 hours. And you can find the distance by using distance equals rate times time, which will be 50 kilometers per hour times a time of 5 hours. Hours will cancel out, and 50 times 5 is 250. So the next 5 hours, you travel 250 kilometers. The first 5 hours, you travel 225. You add up the total, it will be 225 plus 250. And that will be equal to 475 kilometers in 10 hours. So choice C. One thing to keep in mind with this information, you can also find the average speed for the entire trip. And you have to be careful here. For the average speed, you don't just do 40 plus 45 plus 55 plus 35 plus 55 divided by 5 and add 50 and divided by 6 in this case. For the average speed, you have to use the variation of d equals rt, in which r is equal to distance over time. So you have to do the total distance for the entire trip divided by the total time. So it's going to be 475 kilometers divided by 10 hours. So average speed will be 47.5 kilometers per hour. And this will be a decimal. That is not the same as if you just did each of these numbers and divided by 6. So you can't do that here. You have to do total distance over total time. So just be careful there. Sometimes you do see an average speed question. All right, here is the summary for this page. Next for number 34, how long does a 420-mile trip take moving at 50 miles per hour take? So in this case, you have your distance, which is 428 miles. You have your rate, which is 50 miles per hour. You want to figure out the time. So use the same formula, d equals r times t. This time is distance over rate. So this will be 420 miles divided by 50 miles per hour. And here you have to do 42 divided by 5, which will be 8 2/5. And the units is actually really important as well. If you look at the units, this is miles divided by miles per hour. So So you have to do keep change flip. You got miles times hours over miles. Miles cancels out. The units will be in hours. So you can use the unit to actually help you determine whether or not your answer is correct after you do keep change flip. So once you have 8 and 2/5 hours, you have to figure out how much that is. If you know that 1 hour is 60 minutes, then 2/5 of an hour will be equal to 2/5 of 60 minutes. And 60 and 5 cross cancel form 12, and 2 times 12 is 24 minutes. So this will be 8 hours, 24 minutes. And that will be choice C. So for this question, you have a distance, you have a rate, you use equals RT, and you rearrange it to T equals D over R. Make sure you look at a unit and do keep change flip on the units to make sure that everything is consistent. In this case, you have to use the conversion 1 hour 60 minutes to figure out the part of the hour that 2/5 is, which is 24 minutes. Next one, number 35. If 5 inches on map represents an actual distance of 100 feet, then what actual distance does 18 inches on a map represent? So here you have a scale or a map, so you're going to use a proportion. So 5 inches represents 100 feet. So you have map to real life. Then you want 18 inches on a map equal to X feet. And from here, you can draw your fraction bars. Make sure these are equivalent proportions, and then cross multiply, because these are equivalent fractions. So 5 times X over here will be equal to 18 times 100, or 1800. And you could divide by 5 on both sides to solve for X. So in this case, if you do 1800 divided by 5, you get 3. 5 goes into 36 times. So the answer will be 360. And this will be 360, the answer will be in feet. Choice T. So here you have a map question, and that means proportion. So the keywords for proportion, if you see map, scale, recipe, or rate, all of the signals set up a proportion here. Next we have 36. 2/3 of 18 is equal to 2/5 of what number? So here you have to turn the word sentence to a number sentence. Of means times. Is means equals to. And what number is your variable? Call that n. So 2/3 times 18 will be equal to 2/5 times n. I want to solve for n. So to solve for n, you can multiply by the reciprocal of the coefficient, which is 5 over 2, which will cancel out everything. You also have to draw to the other side. 2 will cancel out with the 2, 3 cancel out with the 18, you have 6 left over. So the answer is just 5 times 6, or 30. So you can check your work here to make sure that n is in fact equal to 30. You take 2/5 times 30. That gives you 2 times 6, which is 12. And you take 2/3 of 18. 18 and 3 cancel out to form 6. 6 times 2 is also equal to 12. So this means that everything is correct. Here you just turn of into times. Is to equals to. And then your variable is n. And you just solve by multiplying the reciprocal to isolate n. Next for 37, the market price of a computer is $D. Its price decreased by 20% in January and later increased by 10% in February. What is the final price of the computer in $D? So this is a percent problem. So for percent, they're out of 100. So it's helpful to actually start with by pretending that D is equal to $100. So if the computer is $100, it just makes your calculations a lot easier. If you start at $100, then you decrease 20% in January. Well, 20% of 100 is really easy to find because 20% of 100 is just $20. So you subtract $20. And the reason why it's the same as a percentage is because we started with a nice round number of 100. So in January, it's going to cost $80 now. But then to go to February, there was an increase of 10%. So here you have to find 10%, not of 100. 10% isn't $10 anymore. You find 10% of the new whole, which is 80. So 10% of 80 is 1/10 times 80. And 0 cancels out, and this means $8. So I'm 0 will be adding $8 to $80. That'll give you $88. So this is the final price. So this final price is, in terms of the original 100, you can do percent change, which is new minus old divided by old times 100%. So in this case, the new is 88 minus the old price of 100. You're dividing by the old price of 100, and you're multiplying by 100%. Because we started out with 100, and everything works out really nicely. 100 cancels out with the 100. 88 minus 100 is minus 12%. So when you lose 12%, that means you're really multiplying by 0.88. And also this 88 versus this 0.88 here, choice B. This is 100% minus 12%, which is equal to 88% of the original. So that's what the percent change tells us. There was an overall 12% decrease. So notice that when you subtract 20% and you add 10%, the net change is not equal to minus 10%. Just because 20 minus 10 is 10, that's not how percents work. The second percentage of 10% is only $8 as opposed to $10 because the value of the total decreased. Because it started out as $100 and it decreased to just $80, the second 10% is now not as strong because the second 10% is only $8 as opposed to $10. So that's why the total is 88. When you have these percent problems, you have to be careful. Just like when you add 10% to a price and you subtract 10%, they don't cancel out because the total changed. So because of that, the second 10% is actually stronger than the first 10%. Again, in this case, it's a little different. Just the second one is actually weaker than the first one because you subtracted first and then you added. So just be careful with how percents work. In this case, you can start with percent, which is out of 100, and then you can use a percent change formula here after you keep track of this $100 computer. And just be careful with how percents work. They don't cancel out because a whole change. If there's a new whole, then the percentages will change. So just be careful of that. And here's the summary for this page. Next, for number 21, Jenny writes the numbers into a 3x3 table so that the sums of the 4 numbers in each 2x2 area of the table are the same. The numbers in 3 of the cells in the corners can already be seen in the diagram. What number does she need to write into the cell in the 4th corner? So this number here. So what this is saying is that you have this box of numbers and then each of the 4 numbers in a 2x2 box. So if you put this over any of the 4 numbers, so over here, or over here, or over here, or over here, they're all the same. So it's the same sum. So we can take, let's say, these 4 numbers, whatever they are, it has to add up to the same sum here. So now these 2 numbers are the same. So if you look at just x and y, and let's say a and b, x plus 4 plus a plus b, which is these 4 numbers, has to be equal to the sum of these 4 numbers, which is y plus 3 plus a plus b. So a and b cancels out because you can subtract a and subtract b from both sides. So that means that x plus 4 has to be equal to y plus 3. And in this case, if you subtract 3 from both sides, you get that x plus 1 is equal to y. So y is just x plus 1. And then you can take this into the other corner. So you can replace y with x plus 1. And then you can call this, let's say, c. And now you have these four, 2 plus x plus a plus c has to be equal to these four, which is a plus c plus question mark plus y, or x plus 1. And in this case, you want to solve for this question mark. So you can subtract a and c from both sides. You just get 2 plus x. It's going to be equal to this question mark. You can call it x, or not x, you call it z or something, plus x and plus 1. So now you can also subtract x from both sides. And you get that 2 is equal to this question mark, mystery number, plus 1. So this mystery number has to be equal to 1. There must be a 1 over here. Choice B. So we figure this out by just calling each of these a variable and then using the fact that you have the same sum and then just subtracting the common numbers in the middle, which is just C, A, and B. Next, for question number 22, here you have a shape that's made up of a triangle and a circle that partially overlap. So here the gray area is 45% of the entire area of the shape, and the white part of the triangle is 40% of the total area of the shape. What percent of the area of the circle is the white part outside the triangle? So to figure out this question, we have to use percentages. And percent is just part over whole. So in this case, the gray portion is 45% of the entire shape. So the entire shape is this, plus this part, plus that. So the gray, which we put here, will be 45. Whereas the white part of the triangle is 40% of the total, so that's this part here. So if you add 40 plus 45, you get 85, and 100 minus 85 is equal to 15. So this last remaining part is going to be 15% of the total. Now what you want to find is the percent of the area of the circle, and of represents the whole. That is the white part outside the triangle. So is represents the part. So this is a is over of question. This is part over whole. And the is part represents the white part outside the triangle, which in this case refers to the 15. And you're taking that over the of, which is the whole, and of the area of the circle. So the area of the circle, you don't know what it is, but it's 45 plus 15, or 60. So your fraction is 15 over 60. It's just part over whole, and 15 over 60 is equal to 1/4, or 25%. So the fraction is going to be choice B, 25%, because this is a is over of problem, which is part over whole. In this case, the whole is now switched to just this circle, or this 45 plus 15 part. Now everything is taken with respect to the total area, so you don't know what that is. So this is really 45% of t, 15% of t, and 40% of t. But either way, when you take 15% of t divided by 45 plus 15% of t, the t still cancels out. So this still boils down to 15 over 60. So for this question, you just have to use part over whole and use the percentages to identify the is, which is the part, of is the whole. All right, next for number 23, the numbers 1 through 8 are written on the circle shown so that there is one number in each circle. Along each of the 5 straight arrows, the 3 numbers in the circles are multiplied, and the product is written next to the separate arrow. How big is the sum of the numbers in the 3 circles on the lowest row of the diagram? So you have numbers 1 through 8, and you're multiplying them in some way so that these are going to be your multiples of these factors. So you have to know your times tables here. So if you look at the factors 1 to 8, you see if they overlap, there's going to be some common factor. So for example, you can start with some of the weird prime factors, like 5. The multiples of 5 have to end in 0 or 5. And we see that 30 and 105 are the only ones that are multiples of 5. So that means if you look at these lines, they overlap here. So that means that 5 has to be here. You can't put it anywhere else, because if you put a 5 here, that would mean that 48 is a multiple of 5, which it's not. Or if you put 5 over here, that means that 144 is a multiple of 5, which it's not. So 5 has to be over here, so that it lines up with the 30, it's also 105. So once you know that, you can do 30 divided by 5. These two numbers have to multiply to get 6. And then these two numbers have to multiply together to get 21. Now 21 is another weird number, because 21 has a 7 in it. So one of these has to be a 7. And 7 is not a factor of many other numbers except for this 28. So if you look at 105 and 28, they have a common factor of 7. So if you look at where they overlap here as a common factor. So 7 has to be here. So it overlaps with the 105 and this 28. You can't put 7 anywhere else, because neither of these numbers are factors of 7, or excuse me, multiples of 7. So if 7 is here, 5 is here, that means that 3 has to be here. So if 3 is here, that means that 3 cannot be here for 2 times 3. So this has to be 6 and 1, because the only factors of 6 are 1 and 6, 2 and 3. So one of these has to be 1, the other one has to be a 6. And looking at the multiples of 6, we see that 144 is a multiple of 6, as well as 48, but 28 isn't. So this cannot be equal to 6, cannot be in this row, so 6 has to be here. And if 6 is here, that means that 1 has to be here. And if 1 is here, you know that 1 times 4 times 7 is 28, so 4 has to be here. And from here, you can just start filling everything in. 6 times 4 is 24, times 2 is equal to 28. And then the last number is 8, which has to be over here. And you can test 6 times 3, which is 18, times 8 is equal to 144. So everything does check out. That means that 3 numbers in the bottom row is 2, 7, and 8, and you want to sum. So you have to add, and that gives you 17. Choice D. So the key for number 3 is just common factors. And we have a common factor, number factor times a factor is equal to product. And you can also use the process of elimination to figure out where do the factors belong. I would start with the weird factors like 5 and 7, because those are some restrictions for your multiples. So only 2 of these numbers are multiples of 5, only 2 of these numbers are multiples of 7, so I would start there. You don't want to start with 2, for example, because 4 of these numbers are multiples of 2, so you don't really know where to put 2. So start with the ones that are kind of weird and don't really have that many multiples, and eventually everything will fall into place. All right, next for number 24. By bike, it takes Mark 20 minutes to go from home to school and back. He rides the entire distance with constant speed, and by foot, it takes him 60 minutes for the same distance. And he also walks at a constant speed. Now, yesterday, Mark took his bike to go to Eva's house, which was on the way to school. He left his bike there and continued on foot to school. On the way home, he first walked to Eva's house and then cycled the rest of the way back home. And he needed 52 minutes for the entire journey from home to school and back home. Which part of his journey did he cover by bike? So here you have distance, rate, and time. So you're going to have to use D equals RT for number 24. And now we have the regular distances. So by bike, it takes him 20 minutes to go from school to back. So you don't know the distance to the school, so you can call that D. From home to school, we have a distance of D, and it takes them 20 minutes to go there and get back. So that means that'll take them 10 minutes each way. So we have the distance to school is equal to the biking rate, RB, times 10 minutes. So you want to use this in terms of hours. So this would be 1/6. Because 10 minutes is 1/6 of an hour. So that's his biking rate. Now you also have his walking rate. So for walking, if you walk there and you walk back, it'll take 60 minutes the entire trip. So that means it'll take 30 minutes. So the same distance will be this walking rate times, because it's because 30 minutes, that is 1/2 of an hour. So we can kind of see the relationship between the biking rate and the walking rate. Biking is going to be 3 times the walking rate, because it takes 3 times longer to walk there. So that means you're biking 3 times faster than you walk. Now, in this case, you're going to make a pit stop at Eva's house. So this means that from along this distance, you're going to stop at some point E, and you could be biking this distance. So you can call this the distance to Eva's house, or let's call it distance A, and we have distance of B, where the distance of A plus the distance of B is equal to the regular distance to school. And in this case, you're biking. So the rate of your biking and the time, which you don't know, the time it takes to bike, if you multiply them together, that will be equal to the distance of A. So go to RB times T of B. We have that equation. But then he's going to be walking the entire, for the rest of the trip. So to walk, you'll be taking a walking rate times the time to walk. If you multiply them together, D of B will be equal to the rate of walking times the time for walking. And now we have D of A plus D of B is equal to the distance. So that would be RB times the time to bike plus RW times the time to walk will be equal to the total distance. Once you just substitute in here and here. And now we can substitute in the other thing, which is his biking rate is 3 times his walking rate. So if your biking rate is 3 times the walking rate, you can replace RB with 3 times RW. And then also, because of this, you can also relate the times as well. So the total time it takes for the entire journey will be 52 minutes, but it's really going to take 26 minutes one way. So that's going to be the time it takes to bike plus the time it takes to walk. And that will be equal to distance D. So 26 minutes is 26 minutes out of 60. So this will be 13 over 30. That will be the time for TB plus TW. So if you here, if you factor out RW from both of these, you have RW times parentheses 3 times TB plus TW. And in this case, we can then do some more substitutions here. So from here, you can take this information, the fact that TB plus TW, the two times added together, is equal to 13 over 30. And you can rewrite this as TB is equal to 13 over 30 minus TW. And you can take this and substitute in over here. And once you substitute that in, you have the walking speed times 3 times 13 over 30 minus TW. You're adding TW. And this would represent the distance. And from here, we have everything in terms of RW and TW. So we also have distance in terms of RW over here. So this will be the other thing that you substitute in. Since RW times 1/2 is equal to the distance d, this is equal to the distance d, which is equal to this. So we have RW times 1/2. It's going to be equal to RW times, here when you distribute this 3, you have 39 over 30 minus 3 times TW plus just the TW over here. And from here, you can divide both sides by RW to cancel that out. So now you have one equation in terms of the walking time. So you have 1/2 is equal to 39 over 30, and minus TW plus 1 TW is equal to minus 2 TW. And from here, you can add 2 times TW on the other side, or you can also subtract 39 over 30 on both sides. So you have 1/2 minus 39 over 30 is equal to negative 2 TW. And 1/2 is really 15 over 30 minus 39 over 30. And that gives you the distance, or a numerator of negative 24 over 30 equal to negative 2 TW. From here, you can divide both sides by negative 2. And here you just divide the numerator by negative 2, and you get 12 over 30 is equal to TW. So this will give you the walking time. And if you want to put this in, this is in hours. This is really 24 over 30. So you get the walking time is equal to 24 minutes. And since the whole thing took 26 minutes, that means that the biking time will be just 2 minutes. So this person, he took 2 minutes to bike and then 20 minutes to walk the entire way. Now that's the ratio in terms of the time. We actually want the part of the journey, the distances that was covered by the bike, not the time. So we're gonna have to put this back in to the formula for distance. So since he only biked for 2 minutes and he walked for 24 minutes, this is the time. You want to figure out the rate, and his rate of biking is what we have here, is 3 times RW. So his biking rate is 3 times RW. His walking rate is just RW. So if you multiply this through, everything will be in terms of RW. So You take rate times time, because distance equals rate times time. His biking rate times the time, which is in this case 2 minutes, is really 3 times his walking rate times 2 minutes. This will be the distance covered by biking. And you want to compare that to his walking rate times the time walking, which is 24 minutes. This is the distance covered by walking. And here 3 times RW times 2 is really 6 times RW. So this is the biking distance divided by the total distance, which would be the biking distance, 6 times RW, plus 24 times RW. So this is the whole. And notice you can factor out RW from the numerator and the denominator. And what you end up with in the numerator is 6. The denominator is 6 plus 24. RW cancels out. And 6 divided by 6 over 24 is really 6 over 30. And 6 over 30 is 1/5. This is the biking distance. It's 1/5 of the total. And that's how we get choice B. So it's a super involved problem in terms of using d equals rt. And we have something like 4 variables here. So you have to just organize everything, do a lot of substitutions to formally solve this using the 4 variables. The other way to do this, of course, is just to take, a random distance and then of 100, and then just plugging in each of the choices and see how long it would take. So you can also do it that way, but this entire problem just uses d equals rt with a whole bunch of variables for distances, rates, and times. Alright, next for number 25, the 4 villages ABCD are situated not necessarily in this order along a straight road. The villages A and C are 75 kilometers away from each other, and B and D are 45 kilometers away from each other. And B and C are 20 kilometers away from each other. Which of the following distances cannot be the distance from A to D? So here you have A and C is 75 kilometers away. And then B and D are 45 away. But B and C are 20 away. So from here we can have B to the right of C, and if this is 20, then you can have the maximum distance here for AD would be 75 plus 45 plus 20, or 120 plus 20, which will be 140. So 140 is the maximum, so this could be the distance. So that would be wrong here. Okay, we'll look for one that cannot be the distance from A to D. And from here you just rearrange this so that, let's say, B and C aren't in between. If you have, let's say, B to the left of C, so what we have would be A to C, which would be 75. And if B was to the left of C, and if B was to the left of C, that is 20 away. Then, well, D could either be to the right or to the left of B. And B to D is 45 away. So you can either have D 45 away from B or 45 this way. So if we pretend that D is to the right of B, this distance would be 45. 45 minus 20 would be 25. So C to D would be 25. And then A to D would be 75, or rather 75 plus 25, which will be 100. So we eliminate choice C. But if D is to the left of B, this distance will be 45. So then you would have to do 75 from A to C, minus 20 minus 45. So this distance, x plus 45 plus 20 would be equal to 75. So this would be x plus 65 equals 75. So x would be equal to 10 in this case. So you eliminate choice A, which is 10. And then from here, you would just want to rearrange the letters so that you have the last scenario. So the last scenario is actually over here. Instead of having D to the right of B, you can also have D to the left of B here. So B is here and C is here. D could also be 45 to the left. So that means that B to D would be 45. This distance from C to D would be 45 minus 20, or 25. And then A to D would be 75 minus 25, or 50. So that's how you get the 50 here. So the one that cannot be it would be 80. So the four possibilities would be to have A and then C, where you can have B to the right, or you can have A and then DCB. So the first one would be the maximum of 140. This one would be the 50. And you can also have B to the left of C, so you can have A, D, B, C, or A, B, C, D. And this would be the two other distances. The minimum here would be A to D, and this would be 10, and this would be the 100. You just play around with the order here. Next, for number 26, a painter wants to mix 2 liters of blue paint with 3 liters of yellow paint to obtain 5 liters of green paint. He accidentally uses 3 liters of blue paint and 2 liters of yellow paint, and thus produces the wrong shade of green. What is the minimum amount of this green paint that he has to throw away so that he can use the rest to add blue or yellow? So here it's important to organize the information that you have so far. So what you want is 2 gallons or 2 liters of blue. And for yellow, you want 3. So the total would be 5. But what you have is 3 blue plus 2 yellow, which is equal to 5. So now you want to throw away some amount. So let's say you throw X liters away. Now, because you have too much blue, when you throw away X, you're going to want to replace X with yellow, so that you increase the balance of the yellow for this green. So that means that if you throw away X gallons, because right now the blue is 3/5 or 60%, out of the X gallons, if you throw away X gallons, what you're really throwing away is 3/5 of X of blue paint. If you throw X gallons away, 60% of that would have been blue paint. That's a ratio. Whereas for the yellow, if you throw away X gallons, because 40% is yellow, you're really throwing away 2/5 of X as the yellow paint. So in this case, if you throw away 3 minus 3/5 of X, you want this new amount to be just equal to 2. So this is going to be your equation. 3 minus 3/5 of X has to be equal to 2. And to solve for this, you can subtract 2 from both sides. And you get that 1 minus 3/5 of X is equal to 0. Then you can add 3/5 X on both sides. You get that 1 is equal to 3/5 of X. And to solve for X, which is how much you throw away, you multiply by the reciprocal, which is 5/3. So you'll throw 5/3 liters away. And that's choice A. So that means if you throw away 5/3 liters, of which 60% was blue, 20% was yellow, and you add all of that as yellow, you would actually get back to the ratio of 2 to 3, green to yellow. So you can check your work by checking the yellow ratio. So if X is equal to 5 over 3 liters, and yellow was 40% of this, so 40%, or write this as 2/5. 2 minus 2/5 of this X, which is 5 over 3. But then you add all yellow, which is 5 over 3. This should be equal to 3. And in this case, I have 2, which is, you want the lowest common denominator of 3. So this is 6 over 3 minus 2 over 3 plus 5 over 3. This is a 4 plus 5, or 9 over 3, and that is in fact equal to 3. So everything does check out. You throw away 5/3 liters, or 1.6 liters of paint. 40% of that would be yellow, 60% of that would be blue, and you replace all 1.6 liters with yellow, and you would get 3 liters of yellow and 2 liters of blue, which will give you the ratio that you want for the paint color. So for 26, the key was to essentially do part over whole and match what you want, or what you have, with what you want. Next, for number 27, what is the minimum number of cells of a 5x5 grid that have to be colored in so that every possible 1x4 rectangle and every 4x1 rectangle, respectively, in the grid has at least one cell colored in? So you want to color in this grid so that you don't miss. You can't, draw any blank 1x4 rectangle. So what you can do is, if you don't want to have anything filled in, if you color in every other rectangle, here you can't have a 1x2 grid. So you can't have this grid that's not colored with this grid that's on color. But that's kind of too much for 4x1, so you'll essentially erase some of these colored in ones, and if you erase every other one, you see here that you can't have a 1x4 without one of these boxes colored in. They're all essentially covered, because of course you can't have the diagonals. So that would actually just require 6 cells filled in, choice B. So if you want to prevent a 1x4 from being totally blank, then you can bubble in or draw in every other cell and then just erase half of them, and you have this shape. Next, for number 28, Mowgli asks the bear and the panther what day of the week it is. The bear always lies on Monday, Tuesday, and Wednesday, and the panther always lies on Thursday, Friday, and Saturday. On all the other days, they both always speak the truth. The bear says yesterday was one of my lying days, and the panther says yesterday was also one of my lying days. Which day of the week did this conversation take place? So here you can go through all the choices. Go through choice A. So if it's Thursday, this means that this is the panther's lying, and the bear is telling the truth. So the bear is saying yesterday was one of my lying days, and that's the truth. So yesterday, if today's Thursday, yesterday was Wednesday, and Wednesday is the bear's lying day because the bear lies on Wednesday. Now the panther is lying today, and the panther is saying, oh, yesterday was also one of my lying days, and the panther is lying in this case because yesterday was Wednesday, and Wednesday the panther tells the truth. So both of these are true for Thursday, so that would be the answer. Just have to go through all the choices and see which one would make sense. So if you try Friday, for example, if today was Friday, the bear will be telling the truth, and the panther will be lying. So the bear will say, yesterday was one of my lying days, and that's not true. Yesterday was Thursday, and that's a truth-telling day, so the bear will be lying here. And the panther would actually be telling the truth. So it's supposed to lie, so that's wrong. So there's a contradiction, so you eliminate this choice. And you'll do the same thing for Saturday as well, which is same as the Friday. And then if it's Sunday, both of them should tell the truth on Sunday. So if today is Sunday, both of them are telling the truth. For the bear, yesterday was on my line day, that would be a lie because the bear told the truth on Saturday. So you eliminate that. And then for Monday, both of them are telling the truth the day before. So the bear would be lying, and so would the panther. So that would be wrong. So the answer has to be choice A. Not just doing process of elimination. Next for number 29, some points are marked on a straight line. Renate marked another point between every pair of adjacent points. She repeats this process 3 more times. Now she has 225 points that are marked on a straight line. How many points were there to begin with? So you have some, let's model this problem using, let's say, 3 points. You start out with 3, then the next time, if she marks an adjacent, another point in each adjacent point, that would be 2 more. So that would be now 5. And then she does this again. So then you'll add 1, 2, 3, 4. And that will give you 9. And then if she does this one more time, you'll be adding 1, 2, 3, 4, 5, 6, 7, 8. That would be 17. So there's a pattern here. You add, you kind of double the number of points you have. But let's see what happens if you start with, let's say, 4 points. So if you start out with 4 points, and the first time you'll be adding 1, 2, 3 to give you 7. Then the next one you'll be adding 1, 2, 3, 4, 5, 6. And that'll give you 13. And finally you'll be adding another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that will give you 25. So that's the pattern here. The first one, it's constantly doubling, but the first one is always 1 less than the starting point. So this is the pattern that we get after modeling the problem with smaller numbers. So let's say if you start out with, so here the pattern is if you start out with, let's say, X number of points, then to get to the next number, you have to add X minus 1 points here because it's always 1 less first. And then to get to the next round, you'll be doubling this number. So from X to X minus 1, if you double X minus 1, you get 2X minus 2. The third round, you'll be doubling this, which will be 4X minus 4. From the fourth round, because you do this total 4 times, will be 8X minus 8. Again, you do this once here, and then 3 more times. So you do this total 4 times. So if you add all the variables, x, or all the expressions, you have x plus x minus 1, plus 2x minus 2, plus 4x minus 4, plus 8x minus 8. Here you can combine like terms. You have the x plus x, 2x, 4x, and 8x. So everything in orange, you have, remember, invisible coefficients of 1. So there's 1, 2, 3, 4, and then 8, and then 16. So there's 16x. And for the constants, you have minus 1, minus 2, minus 4, minus 8. So you have minus 1, minus 2, that's minus 3, then minus 7, and minus 8 is minus 15. And this is equal to the total of 225 points. And to solve for this, you can add 15 on both sides, and you get that 16x is equal to 240. And then if you divide by 16 on both sides, you get that x is equal to 240 over 16. And then if you subtract, you get 80. 16 goes to 85 times. So you got 15 points to start with. So to begin with, there were 15 points. Now you can check your work. You start out with 15 points. Then the next round, you'll be adding another 14 points because you have to add, again, one less. And then you just keep adding double that. So you'll have 14. The next one will have 28, and then 56, and finally 112. If you add these numbers together, you have, after these 4 rounds, you have 10 plus 10 plus 5, so that's 25. You have 5, 6, 7, 8, 9, 10, 11, 12. And 1 plus 1 is 2, so that's the 225 that you have. So everything does check out. So here, to do this problem, you can model with smaller numbers. And once you model with smaller numbers, you can then come up with the rule. So the rule is, the first one is you add 1 less, then you just keep doubling. So 2, then 4, then 8, etc., then 3, then 6, then 12. So from here, if you start out with x, the first one you add is x minus 1, and then you just keep doubling that. This is times 2, then times 2, and then times 2. Then you have to combine like terms over here, and then set it equal to 225 and solve. All right, next for number 30. In total, there are 2,022 kangaroos and some koalas, so we don't know how many koalas, are living within 7 parks. As many kangaroos live in each park as there are koalas in all the other parks together. How many koalas in total live in these 7 parks? Okay, so we have a total of 2,022 kangaroos, and we have some koalas, and we don't know how many koalas there are, and they're living in 7 parks. So here you can, to make things easy for yourself, you can kind of do the average because you're putting all the koalas together anyway at the end. So we don't know how many koalas live in the parks. So you can call the koalas K. So that in total, if each park, you'll have K koalas. And for kangaroos, I'll just call them roos because they also start with K. You'll also have some kangaroos. Now, the number of kangaroos that live within each park is all the koalas in the other parks together. So that's important because if this is, let's say, Park 1, there are 6 other parks here. And if you look at the koalas from the other 6 parks, each of these will be a K. So there will be a total of 6K koalas in the other parks, which means there will be 6K kangaroos in each park. So that means that each park will have K koalas, and then the number of kangaroos who lives in each park will be all the other parks, the other 6 parks combined. So we're saying that K koalas live in each park, then there will be 6 times K kangaroos in each of the parks. So essentially, there are 6 times more kangaroos than koalas. So if that's the case, if this is the ratio, 6 times more kangaroos than koalas, you take the number of kangaroos, 2,022, and just divide it by 6. So we have 2022 divided by 6. 3 times 6 is 18. I have 22, 6 goes in 22 another 3 times. 3 times 6 is 18. And 6 goes in 42 7 times. So you'll have choice B, 337 koalas altogether. Now you don't know how they're split amongst the 7 parks. So we have to pretend that they're split evenly. Now 337 is not even a multiple of 7, so there'll be some weird decimal, an average of some weird decimal number of koalas in each park. But if you take that number of koalas that you multiply by 6, that would be the number of kangaroos in each, in the entire park. So that's why there's a 6-to-1 ratio here. So just be careful with the word other. Okay, and here is the summary for this page. All right, next for number 1, of the following, which has the least value? So for each of these, you can compare fractions using the cross methods. If A over B, C over D, you can do the cross method and see which product is bigger. So you want to compare A and B. That's 2/3 and 3/5. Here, 3 times 3 is 9. 2 times 5 is 10. So 10 is greater than 9. So A is larger. B would be smaller than that. You want to compare B with C, which is 4 over 7. Here, 5 times 4 is 20. 3 times 7 is 21. So here we see that 3/5 is greater than 4/7. So B is out. 4/7 is even smaller. You want to compare 4/7 with 5/9. Here, 5 times 7 is 35. 4 times 9 is 36. So here, 4/7 is actually greater than 5/9. So 5/9 is the smallest. Now we can use the cross method here. You can also do the cross method, a shortcut of the LCD method. So you can also do LCDs and equivalent fractions. The other method, you can also convert each of these into decimals just by dividing. Next, for number 2, I brought 27 50-cent stamps, and I got this much change from a $20 bill. So you buy 27 50-cent stamps. So you have to do 50 cents times 27. And 50 cents is really half a dollar. So if you take 27 divided by 2, that will give you $13.50. And to get change, that means you have to subtract. So $20 minus $13.50. This you have to borrow. This becomes 9. This becomes 1. So this becomes $6.50. So the stamps cost you $13.50. And you want to get change for a $20 bill, so you have to subtract 20 minus $13.50. And you get choice D. Next, for number 3, you have 4/5 times 3/4 times 2/3 times 1/2 times 0 over 1. This 0 over 1 is a dead giveaway. This is the zero property, which states that anything times 0 is equal to 0. So the answer is just going to be choice C, 0. Next, for number 4, I first wore my headphones on July 1st, which is the Friday. I last wore them on the last day of July, which was. So July has 31 days. So you can draw a calendar. Monday, let's start with the Sunday. Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So in this case, you have July 1st is a Friday. And each week is 7 days, so you just keep adding 7. The next Friday is the 8th, and the 15th, plus 7, that's 22. Another time, that's 29. So that means that the Saturday is the 30th, and 31 is a Sunday. Choice B. So you know that 1 week is 7 days, so you just count forward 7 days after you draw a calendar. That's the pattern. Next, for number 5, you have 10 times 0.1 times 100 times 0.01 times 1,000 times 0.001. Here, you can turn each of the decimals into fractions. So a 1 in the tens place is really 1/10. This is 1 over 100. And this is 1 over 1,000, because this is in the thousands place. And notice that if you multiply each of these pairs, the denominator just cancels out. So you end up with 1 times 1 times 1, which is equal to just 1. Choice A. So turn the decimal into a fraction with the place value. So the place value, this is the tenths place. That's 1/10. This is the hundredths place. So this would be 1/100th. Finally, this one is in the thousands place. So this decimal is 1,000th. And then just multiply and cross cancel. Next, for number 6, the sum of the 99 smallest positive integers and the 99 largest negative integers is the smallest positive 99 integers, which are whole numbers. But these whole numbers could be negative, 0, or positive. It's from 1 to 99. So you want to add them all up. Now, the 99 largest negative numbers are actually from -1 down to -99. Remember, when you have negative numbers, it's the opposite. So -1,000,000 is not large at all. It's actually really, really small. -1 is the biggest negative whole number because it's the closest to 0. So when you add all these up, 1 will cancel out with 1, 2 will cancel out with -2, 3 cancels out with -3, etc. 99 cancels out with -99. And when you add, you just have nothing. So that's going to be choice A. You have 0. Everything cancels out. So just be careful here. The largest negative integers are actually, the number themselves are kind of small because everything is the opposite. -1 is the largest negative integer. It's the closest to 0. -1,000,000 is really small. Next, for number 7, I saved 2 dimes for every 3 nickels. So that means I saved how many dimes? 90 nickels. So here, in that 3 times 30 is 90. So you also have to do 2 times 30 to get the dimes, and that would be 60, choice C. So the ratio is 2 to 3, so that means that you have 60 to 90 nickels. It's the same as the ratio of 2 to 3. You can also do a proportion here and cross multiply. Next, for number 8, you have 1/2 plus 3/4 is equal to 5 over something. So here, to add fractions, you have to make sure the denominator is the same. The LCD in this case is 4. So I have to multiply 1/2 by 2 over 2. So that'll give you 2 over 4 plus 3 over 4. That'll give you 5 over 4. So this has to be 4. Choice A. Number 2, add fractions. You must do the LCD. And when you multiply and divide fractions, you don't do the LCD, you do improper. And that applies to mixed numbers as well. All right, next, for number 9, if angle O is obtuse and angle A is acute, the measure of angle O minus the measure of angle A can never be. So obtuse means greater than 90 degrees, but less than 180 degrees. So the angle looks like this. Acute means that it's less than 90 degrees. So the angle looks like this. So you have an obtuse angle minus an acute angle. There always will be some difference. It won't ever be 0. And that's because that means that an acute angle would be equal to an obtuse angle, and that's only true if it's a right angle, and right angle is not acute or obtuse. So an acute angle can never be equal to a right angle. They don't overlap at all, so it can't be 0. It could be 1, for example, if you have, let's say, a really small obtuse angle, let's say 90.5, and then a really large acute angle, which is 89.5. The difference here will be 1, and this will be obtuse, technically, and this would be acute, technically. Even though they look almost like a right angle, because it's less than 90 and greater than 90, you have acute and obtuse. Next, to number 10, I buried my head in the ground 120 times in 15 minutes. That's an average of how many times every 3 minutes. Here's another proportion. 15 divided by 5 is 3, so you also have to do 120 divided by 5. That will give you 24. So the ratio here is 120 over 15 is equal to 24, or x over 3. You can also cross multiply to double check. Next, for number 11, the reciprocal of 10 exceeds the reciprocal of 100 by. So reciprocal means upside down fraction. Right now they're whole numbers, so the denominator is actually 1. So when you do the reciprocal, you have 1/10 versus 1 over 100. And 1/10 is 0.1. 1 over 100 is 0.01. So when you subtract 0.1 or 0.10 minus 0.01, you got 0.09. And that's choice B. So here, make sure you line up the decimals when you have place values, so the place values are aligned. Next, for number 12, you have 100,000 divided by 100 times 100,000 divided by 1,000. So here you can cross out the zeros. The first number is 1,000, and then cross out 3 zeros here. The second number is 100. So 1,000 times 100, you count 1, 2, 3, 4, 5 zeros. That will be choice A. 100,000, which is 10 to the 5th power, with the 5 zeros. Next, for number 13, the greatest odd factor of 2007 minus the least odd factor of 2007 is. So the biggest odd factor, remember, factor times the factor is equal to product. So in this case, number's 2007. Well, 2007 has a factor of 1 and 2007. This is the biggest, and both of these are odd. So the biggest odd factor is 2007. The least odd factor is 1. So 2007 minus 1 is going to be choice D, 2006. There are other factors here, like if you do 3, this would be 600 something, but in this case, don't really care about that. You just want the largest ones and the smallest one. Next, for number 14, you have 9/10 plus 900 is equal to 9,000 plus something. So 9/10 is 0.9. 900 is 0.09. So if you add 0.9 plus 0.09, again, line up the decimals, you get 0.999. That's equal to 9,000, which is 0.009 plus something. So you can do 0.99 minus 0.009 to get what that missing number is. Because the equation is 0.99 is equal to 0.009 plus x, you can subtract by 0.009. And when you do so, you put a 0 placeholder here. So this would be 981. Which is choice B. If you add 0.981 plus 0.009, you get 0.99 or 990, which is what you have on the left side. Next, for number 15, the sum of a number and its reciprocal is never. So you have a number which you can call x. Its reciprocal will be 1 over x. When you add these numbers up, they could either be positive and positive, could be positive, or it could be negative, and the number is negative. So if you have, let's say, 2 plus 1/2, that's 2.5, that's a positive number. It can also be negative. If you have negative 2 plus negative 1/2, it will be negative 2.5. So it could be that too. And it could be 1. It could be 2 if it's 1 plus its reciprocal, which is 1, you get 2. So the answer is 0. It can't ever be 0 because 0 doesn't have a reciprocal. If you do 0 over 1, the reciprocal is 1 over 0, which doesn't exist. You can't divide by 0 in math. So you cannot divide 0 in math. So 0 doesn't have a reciprocal. Because if you have, let's say, 0 over 2, the reciprocal will be 2 over 0, and 2 over 0 doesn't exist. It's not a number. So since 0 doesn't have a reciprocal, it can never be 0. All right, and here is a summary for this last page. Thank you everyone for joining me today. Enjoy the rest of the day, and I'll talk to you guys in the next one. All right, bye everyone.